Our last two trig functions today, graphing secant and cosecant. If you were good at the tangent cotangent, today is almost identical with one little twist at the end of it. And that is, again, our focus on the denominator. The first half of graphing these is going to look like we're doing the same thing we did yesterday. Cosecant, this is the mathematical way of showing reciprocal, shows us that the denominator, if we were to think of this as a fraction, is sine. And just like yesterday when sine was the denominator of our cotangent curve, we go to the graph and we dot out a sine curve. So I put my dots on here. Today, all dots are important, not just the ones on our midline. Just like yesterday, every dot that hits my midline means sine has a value of 0. If I were to put a 0 in here, cosecant would be considered undefined. So at every place that it hits my midline, I draw in an asymptote. Again, very similar to yesterday. The difference is this, the dots off of our midline actually mean something today. Because they are direct reciprocals of each other, I just turn the value of sine upside down to get the value of cosine. Well, when I do that, for example, a number that's really easy to reciprocal or turn upside down would be like 1. If you turn 1 upside down, it's 1, right? So sine has a value of 1 right here, which means when I turn it upside down, sine and cosecant will have the same value, which is why you'll see my cosecant curve start at the dot that I had drawn for my sine curve. Other dots, I'm going to talk through why it ends up looking like this, but it's the last time I'll ever actually kind of put a dot in our picture for anything other than that very first one. But basically every value of sine is getting turned upside down. For example, my hand trick people at pi over 6, which would be like really close to our y-axis here, at pi over 6, sine has a value of 1/2. When you turn 1/2 upside down, what do you get? 2. So that sine curve that was sitting right here, and it has a value of 1/2 at about pi over 6, our cosecant has a value of 2. And you can see that every one of these little dots that would have followed our sine curve is now going to go this direction. And so this little shape kind of looks like a little parabola, and that's what we're going to draw up here, a little parabola. But it follows your asymptote because it will forever get closer and closer to that asymptote as it increases. And then as we switch to the quadrants where sine is negative, cosecant is negative, which is why you're going to see down here, all of these head the other direction, a negative parabola. And so all you have to do to draw in a cosecant curve is start at the dot that you drew for your sine curve that's off of your midline, and parabola away from your midline. You need one dot. The dot that you already drew when you drew your sine curve, which is why I say these are the easiest ones to draw. Okay? All right. With that being said, now cosecant, or secant. Same idea. Denominator becomes cosine. So we do the exact same thing we just did, except for I'm going to dot out a cosine curve, put in my asymptotes, parabola away from my midline. Dot out the denominator. Every place that cosine hits the midline is the asymptote. Every place that cosine does not hit the midline, meaning those dots that are off, our maxes and mins, become the vertex of the little parabola I draw between the asymptotes. There is only a requirement of the one dot that you already drew. You don't have to go all the way outside. If you want to draw a full parabola, that's fine. If you want a half parabola, if you don't want to draw those at all, that's fine. But every set of asymptotes you do have to have drawn between. Questions? In your book, it does give you all of the different properties of your cosecant and secant graphs, and it kind of, again, looks highlighted off to the side that remembering where the asymptotes would be is something that we would need to know, and it isn't. We have to remember what creates those asymptotes for us, and for a cosecant graph, those asymptotes are created when our sine curve equals 0 or hits the midline. And for a secant function, it's when your cosine function equals 0 or hits the midline. We don't have to remember those formulas. We just have to remember what the denominator is. Okay? So graphing then a transformation of those is going to, again, look very similar to yesterday. I start by identifying the denominator, rewrite the equation using the denominator, start graphing the denominator, just don't connect the dots, right? So this is a cosecant. Cosecant is 1 over sine. So that's why I pick sine to rewrite my equation. Sine of x plus 2. So we're going to go through and kind of see all the different transformations, similar to what we did yesterday, a little faster this time. We only have one transformation in this particular graph. What is it? A vertical shift, right? We would move this up 2. So numbering does not change from negative 2 pi to 2 pi. I need to draw my midline up 2, and remember, once I have drawn my midline up 2, that the entire function is now centered around that midline. It has nothing to do with our x-axis, all centered around my midline. I have done every transformation that's on here, so now I dot out my sine curve, centered around my midline. Yep. So I'd start there, over 1, up 1 from my midline, back to my midline, down 1 below my midline, back to my midline, all relative to my midline. Every place the sine curve hits the midline is the asymptote. I don't really care how far you draw those, but they do need to be in there. Not optional. So asymptotes are not optional, and then your parabolas. And you just need one dot for it. The dot that's already there, I use that to be the vertex of my parabola, and your parabolas must alternate and go away from your midline. There's a vertical shift. Questions? Okay. This one I think you can do on your own. Secant of x minus pi. Let's see one with a phase shift. What's your denominator? Cosine. In which direction are we moving? Right pi. This is actually one of the rare cases, and I don't know if anyone caught it or sees it or not, because the distance we move for our phase shift, if you were to double that distance is the length of the period. If you were to go right instead of left or left instead of right, it's actually going to look like the exact same thing. So if you went the wrong way, it's going to save you on this particular example, because left pi and right pi end up giving you the same graph. But we should start right pi. That should have been our first dot for our cosine curve. To the right pi above our midline 1, and then we fill in our pattern. So midline below, midline above. Every place my graph hits the midline, I fill in my asymptotes. And again, I am actually using the dots that are off my midline parabola away from the midline. So I should have these in here. You only have to fill in between, but if you would like to fill in outside of here, you can. Doesn't matter to me. All right. We do need to see an amplitude, and we need to see an ROX would kind of be the last ones that are really going to change much in our picture. So let's go through one more example here that has those. And I know this example has a lot going on in it, so we'll kind of work our way through all of those different transformations. But negative 2 cosecant 2x plus pi over 2. It's a negative 2, and I think it's a little bit different than what's on your note sheet, so make sure you guys kind of get that adjusted there. negative 2 cosecant 2x plus pi over 2. Again, what's our denominator? We start with that. Yep. Because that tells me what to write it as and what to dot. This is a good time to remind yourself that we did have an order to attacking a graph. We always started with if I needed to renumber my x-axis. Do we need to renumber our x-axis on this one? Yes, there is a b value, right? If b is 2, what's the period? So I'm going to kind of hijack the numbering here because I don't want to redo that. So it should go from negative pi to pi. That did make the phase shift a little tricky on this one if you weren't paying attention, because our phase shift, no vertical shift, right? So our midline is still here at 0. But there is that phase shift, and you are supposed to move, what's plus? Left. Pi over 2 is usually the first tick mark, but because we renumbered, it's actually the second tick mark up there, right? So I actually need to move left all the way to pi over 2, which would be here. It is a sine curve. Sine curves start on my midline. That dot right there should have been your first dot in this picture. On the midline, 2 lines to the left. And then paying attention to your last transformations on this, we have an amplitude of 2, and we have an ROX. So remember what that means about when we graph our sine curve. From our first dot, normally I would go over 1, up 1. But because of the ROX, I'm going to head down instead. And because of the amplitude, I'm going to head down a distance of 2. That should be my second dot. ROX means down. Amplitude of 2 means a distance of 2. Return to my midline. Up 2, return to my midline, down 2, still in my pattern. So talk about the ROX and the amplitude and its impact on secant and cosecant. You need to get those into the sine or cosine curve that you are dotting out, but then they're taken care of. My asymptotes still don't move. Because I graphed the reflection here, it has taken what would have been the parabola up there and moved it down here, so the reflection is taken care of. The amplitude is shown in the distance our dots are from the midline here, so we don't have to change anything about how you draw in your parabolas. You've already shown the amplitude by putting those dots 2 away from your midline instead of 1 away from your midline. Question? Any that has an amplitude, yeah. Any secant and cosecant. Remember, like on tangent and cotangent, how we had to change that because we had to draw 3 dots for each of those to show the amplitude? The amplitude's taken care of right here. Okay? Questions? Then we're going to skip this example, and we are going to finish up filling in our last 2 on our trig summary sheet. Make those beautiful. While you are filling in your trig summary sheet, I am sending around your assignment. I'm going to give you a helpful hint on the last part, which is multiple choice. Actually, it's a really challenging multiple choice. If you do need help with your perfect graphs, go ahead and look up here. If you don't, if you got them from your notes and you're feeling good about it, go ahead and start on your worksheet. You guys have a half an hour. This worksheet should be done before you are out of here, okay? But eyes on the board, if you need help or want to check that you got a perfect graph drawn for cosecant, remember that your denominator is sine. Normal numbering from negative 2 pi to 2 pi. Don't forget to number your y-axis. I'm noticing a lot of people are forgetting the y-axis. It's a sine curve that we are dotting out for this one. Make sure your asymptotes end up in the right place, that your parabolas are heading the correct direction. And for our secant curve, we should dot out a cosine. Asymptotes, every place it hits our x-axis. Make sure your asymptotes match mine. And parabola away from your midline.